Alright guys, so here we are looking at the benchmark review. There'll be two different videos, one for each page. Hopefully this time it won't be like the last one. Alright, so let's get going. The figure below is a trapezoid. What is the slope of the bases? So in a trapezoid, even though this is something we haven't covered yet, the bases will be parallel. So those two lines are the bases. They should be parallel with each other. So as long as you find the slope of one of them, you'll be good. Now, you see a point there, you see a point there, you could use those. But if worse comes to worse, and you're unsure, always use the endpoints because that's definite. So that's down 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. So negative 4 over 8, which reduces to negative 1/2. Okay, so that's the slope of number 1. Number 2, write an equation parallel to the base, to the bases of the trapezoid and passes through point 25. So I need some excess space. We'll use it over here, I guess. So two things you need to write an equation: slope and a point. So if I'm parallel to the trapezoid, remember parallel means the same slope. So if that's a negative 1/2, I'm going to use slope negative 1/2. And my point they're giving me is 2, 5. All right, so from here, you're going to use point slope because you don't have an intercept. And so that's going to set up, because remember, this is x1, y1. So you're going to get y minus 5 equals slope times x minus x1. And then it's a two-step process. Distribute the slope, the 1/2 in this case. All right. So negative 1/2 x. Negative 1/2 times negative 2 is positive 1. And then plus 5 plus 5. Your equation should be y equals negative 1/2 x plus 6. All right. So I'm going to erase this over here, and then I'm going to use it for 3 as well. So, if you missed the work, just rewind the video, go back and see it again. Write it down if you need to. So for number 3, we have to write an equation that is perpendicular to the base of the bases, perpendicular to the bases of the trapezoid, and passes through negative 3, negative 2. So first of all, perpendicular, key there. Remember, perpendicular slopes are going to give us opposite reciprocals, right? So you see up here, if I have a negative 1/2, the perpendicular slope is going to be, flip that, change the sign to positive. So that would be a slope of 2, and they give me the point negative 3, negative 2. And then just like before, set it up. So these minuses, or the negatives with the minus, are going to cause pluses here, but we'll do this first. Y minus negative 2 equals 2 times x minus negative 3. That becomes plus. All right, that becomes plus. I didn't make them pluses at all, did I? And then again, 2 steps. Same idea. Distribute and then cancel that 2. So you're going to get y plus 2 equals 2x plus 6. Second step, subtract the 2. Y equals 2x plus 4. And that's your answer for that one. All right. So it's not a lot of work. It took a little time to get through those questions, but just to make sure I go through everything, but there probably will be several questions on the benchmark about writing equations. So just make sure you have that down. You will have equations available to you tomorrow. That's the plan, at least. For 4, use the following picture for parts A through F. Which lines are parallel if 2 is congruent to 13? So, if the angles are as we say they are, remember, alternate interior, alternate exterior, and corresponding angles are congruent. Consecutive interior, same side exterior, supplementary. So if those are not true, if those relationships aren't there, the lines aren't even parallel. So this says which lines are parallel if 2 is congruent to 13. 2 and 13 are alternate exterior, right, because we're ignoring this. So here are my 2 parallel lines. This is the transversal. They're outside the 2 lines and they're on different sides. And so the 2 actual parallel lines are P and Q. Again, this line and this line, which are parallel. Which lines are parallel if 10 is congruent to 15? 10, 15. So what I'm ignoring is all this up here, okay, which means this line and this line are parallel because those are alternate interior, and that's congruent. So those are M and N. Question C, name the angle relationship for 13 and 12. So here's 13, here's 12. We're ignoring this. Okay, outside the 2 lines, different sides of the transversal, that is alternate exterior. And I'm going to abbreviate those because my handwriting's bad on this as it is. Name the angle relationship for angles 5 and 10. So, erasing that. 5. Oh, that's a highlighter. 5 and 10. Alternate interior angles, right? We're ignoring this. They are in between the 2 lines. That's the interior. All right, I got interrupted there, so I actually stopped this, but you don't know that because I hit pause and it sounds like it's just continuing. Anyways, 5 and 10 inside the 2 lines, opposite sides, that would be alternate interior. There are 2 questions on the second column that go back to this picture, so I'll kind of have to move it back and forth. We'll read the question and then look at the picture real quick. E, identify the transversal between 7 and 12. So 7 and 12, excuse me. You have 7, you have 12. So we don't ask this question very often, but what's the transversal? So we're ignoring this. P and Q are the parallel, which means N is the transversal. Right, so we'll scooch over there. Identify the transversal between 5 and 8. That's the next question. Five and 8 are here and here. Did I do that right? Yeah, 5 and 8. So ignoring this, M and N parallel, P is the transversal. All right. All right, so 5 and 6 are talking about counterexample, and the good news is this is a benchmark. It's multiple choice. You don't have to write things out. But when you're choosing your answer, do keep something in mind. When you do a counterexample for both of these, the hypothesis must remain true. The if-then must be true. So for number 5, you are playing a sport, but you're not using the spherical ball, right? So the second part you want to change that. So, you could have any kind of answer of any sport that doesn't use a spherical ball. The 2 that come to mind, obviously, most quickly would be football and hockey. but there's tons. And honestly, they're not going to be this easy on the benchmark if they're asking for counterexamples. They're going to be math related. That's why the key is, though, make sure if it's asked in an if-then statement that you keep the first part true. All right, and the number here on 6, give a counterexample. So it is divisible by 10, but not by 4. And really what you're going to wind up with is any odd multiple of 10, 10, 30, 50, 70, 90, and so on, on forever just about. But yeah, make sure the first part of it stays true for a counterexample if you're using the if-then. Last two, find the values of x, so just some algebra here. So, understand what you're looking at. The only thing you know for sure is this is a straight line. Because that's a straight line, these make a linear pair. Linear pairs are supplementary and add to 180. So 3x plus 18 equals 93. Nope, that's wrong. Sorry. See, even I made a mistake. That's 3x plus 18 plus 93 equals 180. Combine your like terms, they're on the same side. That gives you 111. Yeah. Oh, that's getting messy. And then 2 steps. Easy algebra here, minus 111. 3x equals 69. Divide by 3. X is 23. Write that one more time. But again, the key to that one and the key to the next one will be knowing what type of algebra needs to be set up. So you have to know the linear pair, you have to know all those things. Here we have vertical angles, right? 2 lines cross. You can kind of ignore the vertical one there. And they're equal. That's the key here. Vertical lines are congruent, therefore you're going to set up one equation equal to the other. 2 plus 3x equals 62. Minus 2, 3x equals 60, divide by 3, x equals 20. And that's it. All right, so that's video 1. I know it's kind of long, but as usual, I want to make sure I go through everything. So check the next link or the next part of my YouTube page for video 2 for the back of the review. All right, see you in a bit.